So now we are going to start with our 13th chapter, that is motion and time. Motion means you all know that we call movement as motion, right? So here in the previous year class we have learned that there are three types of motion. One is straight line motion, other is circular motion, and the third one is periodic motion. Now here in this table 13.1, they have given you some examples of motion and we have to find it out. We have to separate it into categorize it into three different types of motion, that is along a straight line, circular and periodic. Okay. So soldiers in a march past, they move in a straight line. Bullock cart moving on a straight road, it also moves on a along a straight line. Hands of an athlete in a race. We can see that when an athlete is running, his hands are moving up and down continuously. So that is a periodic motion. It is not moving in a circular form. It is not, his hands are not making a circular form. So we cannot call it a circular. It's just moving up and down. So we call it as a periodic motion. Pedal of a bicycle in motion. So when you are doing cycling, the pedal of your cycle moves in a circular form, moves in a circle form. So we call it as a circular motion. Motion of the earth around the sun is also circular motion because it is also moving in a circle form. Now motion of a swing. Yes, when you sit on a swing, the swing moves to and fro. That is front and back, front and back. It is also not completing a circle. So that is why we cannot call it as circular. We call it as a periodic motion. Then motion of a pendulum. You must have seen in a clock. You can see a pendulum being hanged from the clock. Now that pendulum also moves front, back like this, sideways, left, right, right. So that is also we call it as a periodic motion. Okay. So hope you are clear with these examples given, which we discussed right now, that what is the difference between a circular, a straight line, and a periodic motion. Now, when we can see many objects around us which move, right? Now you can see that some objects move very slowly while some move very fast. Now we know that some vehicles move faster than others, even the same vehicle. For example, if we have a bicycle, if we are cycling a bicycle, sometimes we move the bicycle very fast and sometimes we move it slow. So that is according to how much energy or how much fast we are doing the pedaling of the cycle. Cycle moves fast or slow. Okay. So if vehicles are moving on a road in the same direction, so if we stand on a side of a road and look at the vehicles that are passing by on the road, we can say easily that which vehicle is moving fast and which vehicle is moving slow. Now same thing they have explained you with in the activity 13.1. They have shown you two figures which are taken at different time interval. In the first picture you can see that the green car is in the center and the white car is at the last. In the same way in the second picture you can see the green car has come to the front while the white car is still at the back. So looking at these two pictures, when you compare it, you can easily see that the green car is moving fast and the white car is moving slow. Okay. So that same thing they have explained you here in this activity 13.1. So the distance moved by objects in a given interval of time help us to decide which one is fast or which one is slow. So how much the distance an object is covering in a particular time. That from that we decide which one is fast or which one is slow. Okay, so this is what has been explained in this activity. Okay, which helps you to know that how you can come to know whether a object is moving fast or slow. So that same thing they have explained here with the comparison of a bus and a bicycle. So bus is moving faster as compared to the bicycle. So previous we were discussing about how we can decide whether a object is moving fast or slow according to the distance traveled by this by the object in a particular period of time. Okay, now the next is, it was also given in that topic only, that we often say the faster vehicle has higher speed. So in a 100-meter race, it is easy to decide whose speed is highest. How? The one who takes the shortest time to cover that, or the person who reaches on the finish line first, is considered to have the highest speed. Okay, so now our next topic is about speed. How can you calculate speed? Now you are probably familiar with the word speed. In the example given above, a higher speed seems to indicate that the given distance has been covered in a shorter time. Yes, in a short period of time, a large distance is covered, then we can say that the speed of that object is very high. Now, the most convenient way to find out which of the two or more objects is moving faster is to compare the distance moved by them in a unit time. In a unit time means, if we specify some time, for example 1 hour, so we have to see that after 1 hour where have the two vehicles reached and calculate the distance that they have covered from their starting position. So after 1 hour, we have to check the distance covered by two buses. So the bus which covers the maximum distance is considered to be faster. Okay, so how we can calculate the speed, how we can say what is speed, define speed, that the distance covered by an object in a unit time is called speed of that object. So what is speed? It is a distance covered by an object in a unit time. So we must have heard people saying that the speed of the car is 50 kilometers per hour. So what does that mean? That the car covers 50 kilometer distance in 1 hour. That is what we mean. Okay. So this car is moving with a speed of 50 kilometers per hour means the car is covering 50 kilometer distance in 1 hour. However, a car does not move with a constant speed for 1 hour. Okay, so car does not continuously move with a speed of 50. It sometimes it goes above 50 and sometimes it goes below 50 also. So when we say that the car has a speed of 50 kilometer per hour, we usually consider only the total distance covered by it in 1 hour. Okay. So we consider the total distance which it has covered in 1 hour. We do not consider, or we are not the speed with which the car is moving is not very important for us. The importance is given to the distance covered by the car. Maybe the car is moving with a constant speed, or maybe it is not moving with a constant speed. So the speed word here actually means the average speed of the car, not the actual speed of the car. So here is the formula given to you to calculate the speed. Speed can be calculated if you know the distance covered, the total distance covered, and how much time did it take to cover that much distance. If we know that, if we know these two things, then we can know the speed of the object. So the formula is speed is equal to total distance covered divided by total time taken. Now here in this blue box, two different types of motion are given: uniform motion and non-uniform motion. So when an object is moving on a straight path and the speed of the object keeps on changing, then we call it as a non-uniform motion. But when the object is moving on a straight path and the speed of the object is not changing, it is remaining the same, then we call it as an uniform motion. Okay. Now here we saw that we should, to calculate speed other than distance, we also need to know the time. So how can we measure the time of an object? taken by it to cover a certain distance. Okay. It was speed, how to calculate speed. So we saw that to calculate speed you require distance and time. So if we know the distance covered by an object, but how to calculate the time. So that is our next topic, measurement of time. So we know that we come to know the time by looking at a clock. But earlier the people were not having a clock at home to get the exact time. So how were they coming to know what is the time? So our ancestors noticed that many events in nature repeat themselves after definite interval of time. So they noticed that some of the events that are occurring in the nature that keep on happening after some time. For example, they saw that sun rises in the morning and as the day completes again the sun rises again the next day. So they thought that we can say that a day can be sunrise of one day up till the sunrise of the other day. When the sun rises today and we count it as the starting of one day, and when the sun rises on the next day we consider that one day has been completed. Okay, so you have to remember this. What is a day? The time between one sunrise and the next they called is at a day. Similarly, we know that the full moon you see one day on the in the sky, and after some time you see that the moon becomes short in size. As though we know that the moon is not becoming short in size, it is just that we are only seeing that much part of the moon. Okay, and one day we say that there is no moon in the sky, and after some days again the moon comes up. So they consider that a month can be measured from one new moon to the next new moon. Then a year was fixed as the time taken by the earth to complete one revolution, that is one circle round around the sun, that was fixed, or otherwise you can consider it also as the seasons. Once all the seasons are completed, we can say that one year has been completed. So these are the ways how the people in the past came to know that it's a day, it's a night, or it's a month, or it's an year. These all things they counted it like this through the natural things which were occurring in nature. Okay, but they cannot give an accurate time, or they, from that we cannot get the time of short intervals. Okay, like that, for example, we cannot say, as we say it is 8:55 or we say it is 10:05. So they could not say like that, like this accurate time. So for saying such accurate time we need clocks and watches. Okay, so clocks and watches are the time measuring devices that we know. But the working of the clock is complex. But all of them, but each and every clock that also works, it uses a periodic motion. So one of the examples, or one of the most well-known examples of periodic motion, is that of a simple pendulum which used to be there in the earlier clocks. So how does a pendulum work and how does it show the time? So these are the examples given to you of the clocks, that is wall clock, table clock, digital clock. These all types of clock we have seen at our home, right? Now this is how a pendulum moves. It moves from left to right like this. Okay. And so simple pendulum consists of a small metallic ball or a piece of stone which is suspended from a thread from a ridge, and the thread is attached to a stand. Okay. So the metallic ball is called the bob of the pendulum. Okay. It is a bob. The weight that is being attached at the end of the thread, it is called as the bob. Now, initially the pendulum is at rest, means it is at the center. Okay. So this, in this figure you can clearly see what is the difference between the figure A and the figure B of 13.4. In figure A, it is at the center of the screen, and in the figure B you can see the pendulum is moving from left to right. Okay, so this is the difference between the two. 4 and 13.4 A and B. So the difference is that in the A figure it is at the center, it is not moving, and in the B it is moving from left to right, that is from A to B. So the movement, so the motion of the bob, okay, the bob of the pendulum from A to B, that is a to and fro motion, that is, which is also called a periodic motion. We call it as an oscillatory motion also, because it is considered that when the bob moves from A to B and comes back from B to again A, then we consider that it completes one oscillation. We call it as an oscillation. So that is why it is also called as an oscillatory motion. So the pendulum is said to have completed one oscillation when its bob, starting from its mean position O, moves to A, then to B and back to O. This also you can consider as one oscillation. Otherwise, when the bob moves from A to B and from B to A back, when it comes back to A, you can consider that also as one oscillation. Okay, and the time taken for the pendulum to complete one oscillation, we call it as time period. Okay, so the time taken by the bob to come back to A when it's starting from A, then it is called as time period. That time is called as time taken by the bob to complete one oscillation is called its time period. So in this activity 13.2, it is explained to you how you can make this pendulum. Okay, and then they have told you that you uh, have to observe and measure the time taken by the pendulum to complete 20 oscillation. Okay, you have to keep the length of the thread same. You don't have to change the length of the thread from which the bob is hanging. Okay, and you will see that every time the time taken will come the same. But if you change the length of the string, the time period will there will be a difference in the time period. So if you keep the length of the string same, the time taken will come same each time you measure it for 20 oscillation. So in this figure, in this table 13.2, they have shown you one example that time taken for 20 oscillation is 42 seconds. So time taken for one oscillation is 2.1 seconds. Yes. Now one more thing here given is, nowadays most clocks or watches have an electric circuit with one or more cells. This we all know. We have to put cells in the clock, then only the clock works. So the clocks which show you time with the help of an electric cell, such clocks are called as quartz clock, and the time measured by the quartz clock is more accurate than the clocks which were available earlier, that is the clocks which work with the help of a pendulum. Now next is unit of time and speed. We know that we measure time in seconds, minutes and hours. So second is the basic unit of time, whereas minutes and hours are the larger units of time. Similarly, the basic unit of speed is distance divided by time, that is meter per second, and the higher units are meter per minute or kilometer per hour. We know that we never write the meters or centimeters or kilometers in plural. We always write it in singular, that is 50 kilometer, km, not km and kms. Similarly, we write 8 centimeter, not 8 cms. Okay, so these are the things. And in this blue box, they have given you how Galileo discovered a pendulum clock, how we got an idea of a pendulum clock. So this is all explained that different units of time are used depending on the need. For example, we don't say that we are this much hours old, we say this much year old we are, right? So according to which is convenient to us to speak, which type of time unit, according to that only we say to the people, right? So this was about the how to measure time and what is the unit of time and speed, that is the basic unit, and also the higher units of time and speed.